In this video, we'll discuss the basics of setting up a BNI00L7 or BNI00L8 within the ProFace system using the programming software GP Pro X. The GP Pro X is both a programming environment as well as an HMI programming system. Quick review of the BNI00L7 and BNI00L8. These are 16-point configurable I/O modules. They utilize an M12L-coded power connection. They are multi-protocol with EtherNet IP, Profinet, EtherCAT, and Modbus TCP capabilities. We'll be concentrating on EtherNet IP in this video. They have embedded within them REST API and MQTT for IoT applications. Through the L-coded power, I can provide 16 amps on the input or sensor power, as well as 16 amps on the output or actuator power, with the capability of pushing 2 amps per output on this module. Some differences between the L7 and the L8. The BNI00L7, which is part of our black line, has a composite shell that is weld splatter resistant and no display. The silver line, BNI00L8, at a slightly higher cost, has a die-cast zinc-plated shell as well as a display through which I can set the IP address, subnet, mask, gateway, and protocol through that. Within this video, I will be using a BNI00L8, and at the time of this filming, the L7 and the L8 modules are at hardware 1.0.3 and firmware 1.4.0. I'll be using the GP Pro EX programming software provided by ProFace into a ProFace HMI/controller. So we'll go through how that is set up. So on the screen here is the first screen of my setup. I am using an LT4000 series and actually an LT4300 series, and breaking that down to an LT4301 HMI/controller. I'll click next. We'll leave all these choices there. We'll click next, and what I'll need to do here for the device for PLC1, I have this drop down here. I'll choose ODVA, which pulls in the Ethernet IP explicit messaging and Ethernet TCP as a protocol. I'll click next. I don't have to do anything here, but at the bottom here, I'm going to go straight to communication setup. So on this screen, I can go to device PLC1, and this is where it's got the ODVA, Ethernet IP, and what I'm going to come down here is the device name for device number 1. So this is the first device it's going to communicate with over Ethernet IP. So I'm just going to give it the BNI00L8 as the name. I'll click on this little button here, which will open up the kind of configuration screen. So I'll first set my IP address, which is 192.168.11.107. And I will enable implicit messaging. So implicit messaging is the actual cyclic data, which is going to be, in this case, all of my discrete ins and outs going back and forth between the control system and the BALIF module. You'll need to set this USR as an internal memory of the unit, and you will set the address, or the starting address for the 3 words that will hold the control word, the status word, and the scan count. So I'm going to leave this. It's a brand new project. I'm going to set it for 0. I'm going to open up another document here, and this is going to show you that the control word, really the only thing that I use in the control word is bit 0, and that's to enable the scanning control. So by turning that bit on, I'm establishing the Ethernet IP connection between the controller and the BALF device. If I don't turn that on, it does not establish communication. And then for the status word, only bit 0 is utilized, telling me that the scanning control is receiving, and then the scan count is as it's explained there. I don't need to spell that all out. So back to the environment here. So once I choose implicit messaging and I choose my starting USR word here, I got a new tab for implicit messaging. So I click on implicit messaging, and there's a lot of stuff to fill out here. The easiest way for me is to go and import the EDS file. So I'll click on import from EDS file. I'll click up here, import connection information from EDS file. I'll point to the EDS file that I can obtain through the BALF website, and I'll click open. And I'm going to set up an exclusive owner here, so I'm going to choose that. And what I wanted to show here, and you'll see it down here, there are 8 bytes of input, 6 bytes of output, 2 bytes of configuration, and the input assembly instance is 126, output is 127, and the configuration instance is 104. So if I click OK now, all that information is populated. So now what I need to do is, what is the first internal address that will start the 8, that'll hold the 8 bytes of data? So just for ease, I'm going to use 100 for my start word there. Now again, these are words and these are bytes over here. So I have 8 bytes, so I am going to be using 4 words to hold that information. 6 bytes here, so that'll be 2 words. I'll start at internal address 200, and I have 2 words here, or 2 bytes here, so that would be 1 word, and that'll be held in the internal memory word 300 in the USR registry. You can adjust the requested packet interval. Here is your ranges. I'll just leave it as a default of 100, and I usually enable use unicast connection. So I'm going to click OK on that. Now, we're not done yet. So the first thing, jumping back here, I've got to turn on the control bit 0 in the USR memory that I assigned for control and status. So since I set USR 0, so word 0, bit 0 of USR is the one that I'm going to have to turn on to establish communication. So what I'm going to do here is go to the screen tab, and this is where I would create my HMI screens, but I would also do my limited PLC code here as well. So there's an initialize routine here, and this is where I'm going to set this in. So I'm going to go to initialize. I'm going to insert a rung. I'm going to right click on that rung, insert an instruction, click on the magnifying glass, basic instruction, bit basic, output. And then I've got this look like a little calculator icon here. I'm going to click on that. The memory that I have is internal, and the registry of my internal memory that I've used is this USR. Now when I look at this, I see there are 6 zeros in there. And what this 6 zeros are representing, the first 4 is the word, the last 2 is the bit. So if you remember, I need to turn on word 0, bit 0. So leaving this as all zeros, this is bit 0 that's highlighted here, and this is word 0 that's highlighted here. So I click enter, and now I have through an unconditional rung, I will establish the Ethernet IP connection between the controller and the BALF device. Now, when we did our setup, if I come back here, we also set the configuration to start at word 300, and it's 2 bytes, so the whole word 300 is all the configuration is in that one word, USR 300. And what I wanted to show you here was, if I if I break down that word 300, each bit represents the port 4 function or mode and the pin 2 function or mode for each port. Now, pin 4, it doesn't matter if you set that bit high or low, pin 4 is going to be a standard I/O. Pin 2 has a certain function to it. If I keep that bit low, the pin will be a standard I/O pin. But if I set the bit high, I will turn that pin into what we call power mode, which will keep that pin in an output energized state as long as output power is provided to the module. So for any application where you just want a constant pin 2 to be energized, this is where that power mode comes in. 99.9% of my customers are going to leave all of these bits off, but for this case, for the sake of this video, I'm going to turn on this port 8 pin 2. I'm going to put that into power mode. Now, that means that I'm going to be in word 300 bit 15. So I'm going to go back to my initialization routine, and I'm going to insert a branch, and we're going to right click on that branch, insert an instruction, basic, bit basic, output, and I'm going to click on that little calculator icon, and I can, in USR, that's 300 word, and then bit 15, I'll hit enter, and then now I've got that address in there. So I'll explain a little bit more of what's going on here, but I'm going to stop here, and we're going to take this project. I'm going to save it, give it a name. I'll just call it demo. Call it demo 1. And then what I'm going to do here is I'm going to download that to the HMI/controller. So I'm going to click transfer project, and I am going to choose, I'm going to make sure my transfer method is LAN, local area network. I'm going to send project. It's kind of going to go out there and survey what's out there on my network. There is my HMI/controller. I'll click OK, and now we're going to download that. If you notice right now, I have my connection key. If you notice now, I've got a blinking net light. That means that we are not connected. And again, that's one of the bits that we put into that initialization routine. I apologize. This output is already set as on in that power mode, but it should maintain being on once we are connected. So if you bear with me here, we'll watch that percentage hopefully go up here pretty quickly. And once we get 100% here, the HMI off to my right will continue to boot up. We're just still transferring here. So once the transfer is done and we get 100%, we won't quite be done with the HMI powering up with this new configuration. So we'll just give it a moment here. So the download is finished, but we aren't connected yet. I just heard a beep from the HMI. Now it's booting up off of the program that just got transferred, and now the HMI is running off of that program. So now I am connected, and that was that word 0 bit 0. And then I did turn pin 2 on in power mode, so that's where this LED is maintaining that on state. So so there is the setup of the device. A couple of Excel sheets I wanted to show you here. So This information can be found in the manual, but I also broke this down into that I was starting at word 100 and 200 respectively, just to kind of show you that word 200 has the outputs, or word 200 starting at bit 0 is the output 0 through bit 0 through 7, and then of course 200, word 200 bit 8 through 15 is the master outputs. What I'm doing here is breaking it into bytes. So if I look at the data in a byte format, it would show me what that information is. So now if I choose to write any more code, probably in the main routine, I would be using now the 100 bits for my discrete inputs, my 200 word bits for my outputs, and if I wanted to use any of the status information like short circuit or overload, I would be using word 101 and 102 respectively. Word 103 is holding the power status bits. And then on the output side, again, word 200 is the outputs. Word 201 is the restart bits for any output overloads. And then if you're using the BNI00L8, word 200 and in bits 8, 9, and 10 respectively would be your control of the display for the BNI00L8. So a lot of information I kind of say is hidden, but you can still utilize a BNI00L8 within this system to add that particular module and utilize it within the ProFace environment. So I hope this video today and in the future can help you establish a BNI00L7 and a BNI00L8 with a ProFace HMI/controller using their software package GP Pro EX. Thank you.